In lesson 1-2, we will evaluate expressions and identify properties. Okay, an expression is when you have either an algebraic expression or a numerical expression. So we have those two vocabularies in here. Algebraic expression is like the example 3x plus 1. Okay, it's an expression because we don't have an equal sign. We're waiting for a value of x in order to solve the problem. A variable is an unknown value, so like this x is our variable. Algebra is just when we have letters instead of numbers, and sometimes we need to substitute numbers for the letters and then solve. Evaluate means to answer or solve. Okay, order of operations, we'll be talking about this on the next slide. We'll get used to saying PEMDAS. That's going to get us used to the order of operations. We'll learn the order in which we need to complete our math problems. Powers would be like our exponents, and then our different properties. So let's take a look at the order of operations. So PEMDAS, P is for parentheses. Notice I only have 4 items here, but I actually have 6 letters. P is for parentheses or all grouping symbols, so that includes your parentheses, any brackets, and also your absolute value symbols are straight up and down. Okay. E is for your exponent, so any exponents at all, so like a squared or a cubed, you're going to evaluate those second. Then the reason we have only 4 properties here, or order of operations, we actually need to multiply and divide in order from left to right. So this happens from left to right. It doesn't have to be multiplication first. It can be division first, but it needs to be left to right. So in this case, 6 divided by 3, and then times 4. Okay, so 6 divided by 3 is 2, and 2 times 4 is 8. So the correct answer here would be 8. If you did it the other way, 3 times 4 is 12, and 6 divided by 12 is 1/2. Well, 8 and 1/2 are definitely different. So the correct answer is 8, doing it from left to right. Okay, addition and subtraction also happen from left to right. Same thing, subtraction can come first as long as it is first from left to right. So if we did 6 minus 4 plus 2, well, 6 minus 4 is 2, plus 2 is 4. And if we did it the other way, 4 plus 2 is 6, and 6 minus 6 is 0. So they're definitely different answers. There's one correct way to do it, and that's from left to right whenever you have addition, subtraction, and multiplication, division. All right, so here's our different properties. You can take a look here. The commutative property just says that we can turn things around. 6 plus 1 is the same as 1 plus 6, and 7 times 3 is the same as 3 times 7. So that just explains the commutative property that we can turn things around. The associative property, all right, so it says that instead of turning numbers around, we can actually insert parentheses in order to make ourselves do that part of the problem first. I often think of this whenever we have problems that involve easy numbers. For example, 3 and 7 make 10, so a lot of us would want to do that part first. Okay, so 3 and 7 make 10, plus 2 is 12. If we do it in our head, it's easier if we make a group of 10 first. Okay, so when you do that, you may not realize it, but you're using the associative property to do those numbers first. Now, it's different from the commutative property because we're not actually changing the order of the numbers, we're just doing those numbers first. And that is okay when you're doing addition throughout the entire problem or multiplication throughout the entire problem. Addition and multiplication are associative as long as that's what you're doing throughout the entire problem. The distributive property gets a little bit different. You see parentheses, so it makes you think of the associative property. However, you have a mix of both multiplication and addition, or multiplication and subtraction. So I always think of it like a box of cookies. You're going to distribute your cookies to everyone in class. Well, here, since you're multiplying by 4, we're going to distribute the 4 to everything inside the grouping symbol. So over here we get 4 times 6, which is what we're doing there with that loop, and then we're getting 4 times 2 over here. And the symbol is determined by whatever symbol was inside. So if we look at the next one, it'd be 3 times 7 and 3 times 5. We get that 3 times 7, 3 times 5, and the symbol in the middle is determined by that symbol right there. Okay? And then your identity property has to do with just addition of 0 equals A, and A times 1 equals A. It just says if you add 0 to something, you get to keep the same number. If you multiply by 1, you get to keep the same number. It seems pretty straightforward, but we need to understand those properties so when we get working with algebra and I start putting letters in for those numbers, we can remember those properties and be able to manipulate our equations and eventually solve for variables. All right, so in our homework problems, you're going to do it just like this. Okay, first thing I'd like you to do is copy the original problem. So 4 times the quantity R minus S, quantity squared. And then we're going to substitute on the next step. Okay, so I do want to see the original equation. In the next part, we're going to do 4 times. We're going to substitute 6 for R. So we're going to go 6 minus, and S is 3. And we'll go ahead and keep that squared, okay? Now we got to think of our order of operations, PEMDAS. All right, so we do have grouping symbols. So we have to do the 6 minus 3 first. Something I always like to do is I always like to underline the part that I'm doing. So 4 times 3 squared. Okay, so I took care of that part inside the parentheses. Now, I am done with my parentheses. Even though I see parentheses here, there's nothing really to do inside the parentheses, so I can move forward. So next I'm on to the exponents, all right? So I do have an exponent, so I'm going to do this right here. So 4 times and 3 times 3, because 3 squared equals 3 times 3. So I'm going to get 9, okay? And then obviously the next step I'm going to do 4 times 9, and I'm going to get 36. And that's my final answer. So if I was doing this problem for homework, I would have 1, 2, 3, 4, 5 lines of work in my homework, with the 5th line being my answer. This is exactly how I'd want to see it for your homework. Also, if I'm showing it in the notes, you are required to have it in your notes for class tomorrow. All right, again, evaluate the expression. So we're going to do 2 times the quantity, A plus B, quantity squared. All right, now we're going to substitute 2 times A is 3 plus B is 2 and quantity squared. So first thing is PEMDAS. We need to do the parentheses first, so 2 times quantity 5 squared. All right, now there's nothing else to do inside the parentheses, so I'm going to go ahead and do this part here. So we're going to do 2 times, now 5 squared equals 5 times 5. So we're going to get 25. All right, then obviously you have to do 2 times 25, and that's 50, and we're done. Okay, so notice here, something that I do is I underline the part that I'm doing just to kind of help focus me to make sure I'm following PEMDAS, following the rules. All right, again, 1, 2, 3, 4, 5 lines if this were a homework problem in my notebook paper. All right, evaluate. So let's go ahead and copy the original problem, which you will be required to do for homework. Q squared minus 4R minus 1. All right, now we'll substitute. So we're going to do 5 squared. Now, it's always a good habit to get into when you're substituting, especially with an exponent, to go ahead and put the substitution in parentheses. Just in case you were to have a negative value, that would definitely change what it looks like. So get in the habit of substituting with parentheses. So minus 4 times R is 6. Again, notice I put it inside parentheses. That's a good habit to get into. If I were multiplying like 4 times negative 6, okay, and I forgot to put the dot, or maybe I made a dot, but it was really small, I could interpret that as 4 minus 6. So if I put it in parentheses, I know that it's 4 times negative 6. It's a little bit easier to make fewer mistakes with parentheses. All right, so now that we did our substitution, again, PEMDAS, we need to do our parentheses first. Well, really, I don't have any parentheses. So next is exponents. So we'll do 5 squared, which is 25, minus 4 times 6, minus 1. Okay, next thing is multiplication and division. So I have multiplication happening right here. So we're going to do 25 minus 24 minus 1. Now I have all subtraction. So I'm down here at the end. Okay, you have to go from left to right, so I'm going to do this part first. So 25 minus 24 is 1 minus 1, and then I'm going to get 0. Okay, so that's my answer again. 1, 2, 3, 4, 5, 6 lines in my notebook paper for homework. All right, evaluate the expressions. First thing, copy the expression b squared plus 3c minus 5. Now we're going to substitute. B is 4, put it in parentheses. So 4 squared plus 3, c is 2, we'll put that inside parentheses, minus 5. All right, 4 squared. All right, PEMDAS. All right, parentheses first, I don't really have anything to do. Exponents, 4 squared is 16 plus 3 times 2 minus 5. Now I do multiplication division. Well, I only have multiplication, so I'm going to do this part. Okay, let's go ahead and underline what we did. So 16 plus 6 minus 5. Now I have addition and subtraction, but I have to go from left to right. So 16 plus 6, we'll do that first. All right, we'll get 22 minus 5. And then we have to do 22 minus 5, which gives us 17. Okay, and then that would be our final answer for that problem. All right, evaluate the expression 3s divided by q plus 4. Okay, there is an interesting part here. Okay, whenever we have division written like this, there are imaginary parentheses around the top and the bottom. Okay, and the reason they're imaginary is because when you write division like this with the division bar, you don't have to include the parentheses. However, if I was going to write this left to right, I would write 3s divided by q plus 4. Okay, and that necessarily you wouldn't need the parentheses out in front of here because you have multiplication before division, but you definitely need the parentheses over here because we have addition. All right, if we just wrote it 3s divided by q plus 4, you would do the division before the addition, okay? And that's not how we need to do this problem. So we need to think of it as invisible parentheses whenever you have division written on top and bottom. All right, so let's go ahead and substitute. So we have 3 times s is 2 divided by q is 2 plus 4. Okay, again, we have to do the part on the bottom and the top first. So just evaluate. So we go 6 divided by 6. So you take care of the top and you can take care of the bottom. You can always do one step on the top and one step on the bottom at a time. And then we know that 6 divided by 6 equals 1. So we can simplify or evaluate that expression to be 1 with those values of q and s. All right. Name the property shown by 12 times 1 equals 12. Well, I remember that to be the identity of multiplication. Okay, if you look back at your properties, the property table that I gave you, that is the identity of multiplication. When you multiply by 1, you get the same number. All right, name the property here. All right, we're switching the numbers around. 3 times 2 is the same as 2 times 3. All right, that's the commutative property. All right, that's being able to switch it around in any order is commutative property. All right, state whether the following conjecture is true or false. If false, provide a counterexample. The sum of an odd number and an even number is always odd. Well, let's try a couple, okay? Let's do an odd number. 3 plus 2 is 5. Okay, that is odd. That's true. Okay, let's try another one. Let's go 5 plus 4, and that equals 9. So I'm going to go ahead and say because you have an even number and then you're giving an odd number, you will always end up with an odd number. So this is true. All right, division of whole numbers is associative. Division of whole numbers is associative. So if we look at the associative property, that would be like having 3 plus 2 plus 8 and being able to do these two and getting the same answer, and then being able to do them in order, these two, and getting the same answer. If we take a look at that, we get 10 here, and then we get 13, and then here we get 5, which also gives us 13. So we know that addition is associative. The question is division of whole numbers associative? Well, let's go ahead and do 8 divided by 4, and then we'll do divided by 2, okay? Well, if we put these two in parentheses, we get 8 divided by 4 is 2, and then 2 divided by 2 is 1. Now let's do it the other way. All right, let's put these in parentheses, and we get 4 divided by 2 is 2, and 8 divided by 2 is 4. So, since these are not the same answer, they are not associative. So we can say this is false, and this right here is my counterexample. A counterexample is proving a statement false. You can't just say false, you have to also show me an example why it's false. So that is a counterexample.